Hey Mark, give this a look. You can see here I've moved on to looking at some different objects rather than just shapes. But the premise and how everything works is just the same. I actually didn't change any code. I just changed the objects that it's looking at. So it's doing the same thing as I've seen you before, or as I've shown you before with the different shapes. But now we're looking at objects. So obviously the way it draws relations to objects and the different parts of the objects has to change because previously the objects were symmetrical and now some of the objects are asymmetrical. And again, it doesn't look at the whole image. It looks at only a small portion of the image, just as a human eye would look at just a portion of their environment. So for like the brain, say for if you looked at the four different corners or sides or whatever, then you'd be seeing something different in each one. So you'd have to learn these different parts of the brain rather than the image of the brain as a whole. So anyway, that's all the same. It's just a little bit harder for it to learn given the nature of these objects. But everything's worked well. Like I've changed a little bit of how it goes through each generation and chooses synaptic values, which are pretty much like weights. And I've improved it so that it actually trains faster. But I added something that's really, really cool, and that's the reason I want to show you this here. If we look at this, this is the dictionary of like the genetic map. And so here are all the synaptic values that come from this, what I call like the occipital lobe entry that go into the actual like classifying portion of the brain. And right now it's classifying these three objects. And it has these 12 different neurons that house the classification for the three of those. So basically each four, the first four for the brain, second four for the cup, or something like that. So it decides on its own. But basically it's split into thirds. Yeah, this is the value. There's 12 of those now, and there's tons of connections to it. Basically anywhere you see these groups of 12, that's where there's an entry point into what I call the shape-specific or object-specific neurons. So now check out this addition I just made. I'm going to go ahead and run it, and so it's going to continue training. It's been training. It's on its 33rd generation, so it's going to continue training as it has been. So you see it here looking at the brain, but as it gets going, I am actually going to add a new object into its objects folder. And so check this out. After it goes through this first iteration, this first generation, so this generation will all be the objects it was looking at previously because it had started that generation. But now since I added this car, it's going to pop up in the next generation, and the network will make all the changes. The AI will make all the changes to the network to include this car. And so now we started a new generation, seeing the brain again. And so now we'll see a brain, cup, the car, and the kettlebell. This image viewer takes forever. It really slows things down. It's an anticlimactic. Oh, and obviously, yeah, it's going to get some stuff wrong. It has to readjust once you add a new object because there's kind of like new neurons all over the place at first. And then it has to prune them down to get back to something kind of making sense. See, there's the car. The car, all you had to do is drag a new image into the objects folder, and it adds a completely new classification with all the neurons needed to make the classification. And again, the images can be any size and shape. I've got them smaller just because it makes training easier. But you can see the car is irregularly shaped as the others are square. And again, because it just looks at a portion of the image, it scans through the image to find what's of interest. So again, you can have different sized and shaped images, and it all just kind of works out. The network just figures it out on its own. So I hope this is pretty interesting. Let me know what you think, bud.